Krishna Teja Reddy, 3rd SEM CSC student studying in Sri Venkateswara College of Engineering, Bangalore. Today I came with the topic Review of Basic Probability Theory. Introduction to Probability. Key concepts in Introduction to Probability. Probability is a branch of mathematics that deals with likelihood of event occurring. It is widely used in various fields including statistics, finance, and science. Here are some key concepts in probability. The sample space, the set of all possible outcomes of a random experiment. It is denoted by symbol ohm. Event subsets of the sample space that represent specific outcome or combination of outcomes. Probability rule and properties. Additional rule. The addition rule states that the probability of a union of two events A and B is equal to the sum of their individual probabilities minus the probability of their intersection. Multiplication rule. The multiplication rule states that the probability of the intersection of two independent events A and B is equal to the product of their individual probabilities. The complement rule states that the probability of the complement of an event A is equal to 1 minus the probability of A. Conditional probability. Conditional events are the event that occurs based on the occurrence of other event. Calculating conditional probability. Conditional probability is calculated using the formula P of A by B is equal to P of A and B by P of B, where P of A by B is the probability of an event A occurring given that event B is already occurred. Random variables. Probability density function PDF. The probability density function PDF is a function that describes the relative likelihood of different values of a continuous random variable. The area under the PDF curve between two values represents the probability that the random variable falls within that interval. Continuous random variable. Continuous random variable can take on any value with a certain range. The probability density function describes the relative likelihood of the different values of a random variable. Probability mass function PMF. The probability mass function is a function that assigns probabilities to each possible values of a discrete random variable. It provides a complete description of the distribution of random variables. Discrete random variable. Discrete random variable takes a finite or countable infinite number of possible outcomes. The probability mass function describes the probabilities associated with each value of the random variable. Probability distribution. Discrete distribution. The binomial distribution is used to model the number of successes in a fixed number of independent Bernoulli tails. Continuous distribution. The normal distribution is widely used to model real valued random variables whose distribution are not known. Exponential distribution. The exponential distribution is often used to model the time between event in a position process. Expected value and variance. Expected value. The expected value of a random variable is a measure of the central tendency or average value of the variable. It represents the long-term average value that we would expect to observe it. We represent the random experiment many times. The formula for calculating the expected value of a discrete random variable is P of x is equal to summation x into P of x is equal to x. Variance. The variance of a random variable measures the spread of variability of the variable. It represents how far the value of the variable typically deviate from the expected value. The formula for calculating the variance of the discrete random variable is variance of x is equal to summation of x minus e of x to the power 2 into p of x is equal to x. Sampling and estimation. Sampling distribution refers to the distribution of a statistic calculated from multiple samples drawn from the same population. Point estimation involves using a single value such as the sample mean or sample proportion to estimate an unknown population parameter. Confidence intervals. Confidence intervals provides a range of values within which the true population parameter is likely to fall with a certain level of confidence. Hypothesis testing. Null hypothesis. The null hypothesis is a statement that assumes there is no significant difference or relation between variable in a population. Alternative hypothesis. The alternative hypothesis is a statement that contradicts the null hypothesis and suggests that there is a significant difference or relation between variable in a population. Type 1 error. A type 1 error occurs when the null hypothesis is rejected but it is actually true. This is known as a false positive. Type 2 error. A type 2 error occurs when the null hypothesis is not rejected but it is actually false. This is known as false negative. P-value. The p-value is a measure of the strength of evidence against the null hypothesis. It represents the probability of the obtaining the observed data or more extreme data. If the null hypothesis is true, a smaller p-value indicates stronger evidence against the null hypothesis. Let's go to the conclusion of basic probability theory. In conclusion, basic probability theory provides a foundational framework for understanding and equitifying uncertainty key concepts such as sample space, events, and probability measures allows us to model and analyze random phenomena. The fundamental rule, including the additional and multiplicational rule, offer systematic way to calculate probabilities. Probability distribution further characterizes random variables, enabling us to make predictions and draw inference. Overall, a solid grasp of basic probability theory is essential for various fields from statistics to machine learning, provide a basic for informed decision making in the face of uncertainty. Thank you.